All right, let's go ahead and take a look at our Unit 1, Day 5 notes over congruent statements, midpoint, and angle bisectors. As we look at this, then you're going to notice that we do not do all of these notes on the video, so this video should be a lot quicker. But we're going to talk about some highlights, and then we will finish these notes in class. All right. So we're going to take a look first at what the definition of congruence is, and here's what congruence means. Objects with equal measures are congruent. And the symbol for that is an equal sign with this symbol above it. That's our congruence symbol. Objects are said to be congruent if they have equal measures. That means if they're segments, they're congruent if they have equal length. If they're angles, they're congruent if they have equal measure in degrees. And that makes them congruent objects. All right? So we're going to work on understanding the way these markings work to state that things are congruent. To show that segments are congruent, we use a series of tick marks. Okay, these hash marks through a segment. Any other segment with those matching hash marks would be congruent. So in this case, this segment is congruent to this one. They don't always have to be double. Sometimes they're just single hash marks. Sometimes there are other hash marks. And so congruent segments are given here as UT and SR. So we would say segment UT is congruent to segment SR. And you could change the lettering, change the order of these, that's okay. But if you write an equal sign, then we just say the length of UT equals SR. So it's very important that if you're going to use congruence, you have to put the symbol notation above it. Okay? All right? We'll take a look at 2 and even 4 in class. But if we look at number 3, we've got a couple things we can mark congruent. All right? We have congruent segments marked with 3 hash marks and 3 hash marks, or 3 tick marks and 3 tick marks. But we also have these angles with these arc marks in them that match up. 3 of these marks and 3 of these. This is how we mark angles congruent. A lot of times we'll only use a single arc mark at once. So if I gave you this, these angles would be congruent. Okay? We use multiple markings to show different angles. It's not a really big deal. But in this case, we have congruent segments. VW is congruent to WX. But we also have congruent angles here and here. So we would say angle VTW is congruent to angle WTX. And that's how we can mark that angles are congruent. So we have 2 pieces of information there. Like I said, we'll come back to numbers 2 and 4 in class. These are some different markings, not necessarily congruence. These are not congruence markings, but we'll talk about those in class. All right, let's talk about what a midpoint is again. Now, in a coordinate plane, we've talked about how to calculate midpoint, but we're going to talk about midpoints in general right now. A midpoint, remember, is a point that divides a segment into 2 congruent segments. Okay? So we're going to do some work with midpoints in these problems. So you got examples 4 and 5. We're going to do example 4 together in the video here, but we'll do example 5 in class. So we're told that U is the midpoint of TV, and that the length of TU is 3x plus 4, and the length of UV is 5x minus 2, and we're to find the value of x. When it says a sketch may help, I'm not kidding. A sketch is really the only way to work this out until you get used to seeing this. So we're going to just draw a segment called TV. And we're going to make sure that U is marked as the midpoint. So find the location that you assume to be the midpoint, mark it, put a U, and then we're going to fill in the parts that we are given. We are told that TU is 3x plus 4, UV is 5x minus 2. Now, these two would add up to the total just because U is between T and V, but we are told specifically that it is the midpoint. So I also want you to mark segment TU congruent to UV like this. Put those tick marks through there to mark that they're congruent. That means that these expressions should represent the same value. That means they must be equal. So that's how we can start to write our equation. 3x plus 4 equals 5x minus 2. And then we just solve the equation for x. Minus 2 is 2. We're left with 2x there. Divide by 2. X is 1. All right, so there's part of your answer. But you're also told to find TU and UV and the entire length TV. So TU, we're just going to plug 1 in for x here. 3 times 1 is 3. 3 plus 4 is 7. Since you use the midpoint, UV will also be 7, but I'll show you how that works out by plugging it in here. Okay. I just noticed a mistake that I made. Sorry about that. Let's go back and take a look. No need to start over. Let's just fix it. Mr. Allred makes mistakes sometimes also. Notice here that I added 2 to this side. I should have added 2 to this side, making that 6. And dividing by 2, x equals 3. There we go. That's a lot better. So 3 times 3 plus 4 is 9 plus 4, which is not 7. 9 plus 4 is 13. Let's try this. 3 times 5 is 15. 15 minus 2 is 13. There we go. So they're both 13s, not 7s. Sorry about the confusion. Okay? And then the full thing, TV, is just the sum of 13 and 13, or 13 times 2, which is 26. All right? Okay, we will work through example 5, hopefully not making any mistakes on that one in class. Go ahead and turn the page. Example 6 is another midpoint example. We'll do that one in class also. Put a star by these if you want to make sure we come back to them. But I do want to talk about what an angle bisector is now. An angle bisector is any line or segment, I'm going to abbreviate, or ray that divides an angle into two congruent angles. All right? So it'll look something like this. If I give you an angle like this, and I draw an angle bisector, I would always mark it that these are congruent angles then. Okay, this ray right here is called an angle bisector. It splits my big angle into two congruent angles. All right? And so we're going to work on some problem solving using angle bisectors. All right? So we're told here that we have CD and CB are opposite rays. Those are ray notations there. So all of these pieces should add up to 180 degrees. And we're told that CE bisects angle DCF. DCF is this angle. So CE is a bisector that creates congruent angles there. And we're told that CG bisects angle FCB. Now I'm going to mark these two angles congruent differently than these two because they're not saying that all four are congruent, just that these are congruent to each other and these two are congruent to each other. So I'll use double markings for these two, singles for these two. All right, and so here's what we are given. If we're told that DCE is 4x plus 15, DCE is 4x plus 15 degrees, and ECF is 6x minus 5 degrees, these are congruent angles, so these must be equal. So I'm going to do this work right here. All right, and there's we get our equation. The only reason I can say these are equal to each other is because I am told that this is an angle bisector. Bisect means to divide evenly or equally. So we're going to subtract 4x from both sides first. 6 minus 4 is 2x. Then we add 5 to both sides. And then we divide by 2, and we get that x is 10. And we are going to take that and plug it back in so I can find the measure of angle DCE. DCE is 4x plus 15. So I do 4 times 10 plus 15. 4 times 10 is 40, plus 15 is 55 degrees for that angle measure. Okay, so we're going to stop there. We will come back and finish this problem and finish the rest of your notes in class. But that gives you a little bit of an idea of what it looks like to have segment bisectors, which we call midpoints, or angle bisectors, and how to solve problems using congruent segments, using midpoint, angle bisector, and how to identify congruent segments and congruent angles in any diagram.